In exercise 3.9.16, we are asked to show that if y is a random variable with Gompertz distribution, parameters b and c, then we have to show that c to the power y minus 1 is an exponential distribution with some parameter. The key takeaway of this exercise is to know your definitions, especially those of a CDF, and to transform random variables. We saw this in a different exercise as well. If you have to investigate or analyze a complicated random variable, it is sometimes possible to transform it to a simpler one, in this case it's exponential, and then do your calculations there. The key solving ingredient will be the CDF of an exponential distribution. How to recognize it and where to use it, we will see in a bit. Let us first recall from the exercise that if y is a Gompertz distribution with parameters b and c, then its CDF is given by, let's see, is 1 minus the exponential of minus b over log of c times c to the power x minus 1. And from there, we use the definition of the CDF to compute what our wanted quantity is, which is this right here, this c to the power y minus 1. So we just start from the definition of a CDF, which is the following, and we rearrange by doing plus 1 on both sides. Then we take logs because we want to consider y, and recall that if you take the log of cy, then it's y times the log of c. So I will do that and rearrange at once. So we get log of c on this side. Then what do we do? Well, we have now, this is the CDF, right? So this is actually what we will plug in to the CDF, and this gives us 1 minus the exponential of minus b over log of c. And now instead of x, we have this entire expression. So we have c to the power this entire expression, log x plus 1 over log of c minus 1. And then we can rearrange, and we see that I will make some steps. So 1 minus exponential of minus b over log of c, and then we have to rewrite this somehow. So what we can do is let's take a small detour here. So what we can do is that we can write c log of x plus 1 over log of c as an exponential and a log, written one after the other. Right, so because these functions, they cancel, so this is equal. And then we have the log of the c. So this, what is inside the exponential, we can rewrite by taking out the exponent. So this is just actually this rule right here, over log of c times the log of c. And you see that the log of c cancels, so this is, and then we have the exponent of the log of x plus 1, which is just x plus 1. Right? So this is actually just x plus 1 minus 1, which is just minus b over log of c times x. Oh, there we go. And this is actually the CDF of a random variable x, where x is this random variable, which proves the assertion.